Hello everyone, welcome back to the channel. In this video, I am going to explain a logic-based Python project where I reconstructed a large ASCII art image using pure Python logic. This ASCII image represents Diego Maradona, and the most important part of this is I did not use any ASCII converter, no external libraries. I only use loops, conditions, list, tuples and strings. If you are a beginner or want to improve your logic building, this video is for you. So here we go. So what is an ASCII art? First of all, let's understand what ASCII art actually is. ASCII art means creating an image using text characters. For example, as you can see in this image, I use hash, percentage, and asterisk, and many others. So, as you can see, different characters represent dark areas, lighter areas, shadow, and depth. When these characters are arranged properly in rows and columns, they form an image, as you can see in the screen. The main problem with ASCII art is it becomes very large. The same character repeats many times, like in this video. In first row, as you can see, hash occurs many times. So storing this directly is a waste of memory, is hard to manage. So we need a better and smarter way. So here comes the concept of run-length encoding. In simple word, instead of storing repeated characters, stored how many times they repeat. Example like in this analyze data that I already created, like I stored the data in the form of list of tuples. As in this tuple, I stored how many times a character occurs, like hash occurs 35 times. Okay, this makes the data so this makes the data smaller, cleaner, structured. In my project, I first analyzed and compressed the ASCII image using this method. Okay, now let's understand the data structure. As you can see, I store the data, the character in the form of list of tuples in the list analyze data, where outer loop represent the full image and the where the outer list represent the full image and the inner list represent one row of an image, and each tuple represent number of times a character occurs. Okay, so every row of the image is already compressed and ready to be decoded. Okay, so my project goal is convert this compressed ASCII data back into the original ASCII image. So this reverse process is called run length and decoding. So in this project I used function. So now let's move to the main function. So in this project I used a function called reconstruct ASCII art. So let's make a function def reconstruct let's go online. Reconstruct ASCII art ASCII art. So what is the work of this function? This function reads the compressed data, repeats character based on count, prints the final ASCII image line by line. This function is the engine of the project. Okay, next we are going to add a loop which processes one row at a time and reconstruct one ASCII line at a time. So let's make a loop. Use for raw data in analyzed 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 data. Okay. Inside this loop, we create an empty list. This string will slowly build the current row. Okay. So let's create a string equals to, this is an empty list. Okay. Let's go. Next one is the tuple loop. Before understanding the loop, let's understand the raw data. Raw data. What is a raw data looks like? Raw data looks like this represent one row of the ASCII image. Each element inside the list is a tuple. Okay. What is inside a tuple? Each tuple has two values. One is count and second one is the symbol. This means print the character 35 times continuously. So one tuple equals to one continuous block of character in that row. Okay. Now tuple loop, the main point. Tuple loop for for data or data group in raw data. So this is our tuple loop. So let's see what it does. It goes through the row tuple by tuple, and each iteration handles one character group. So it does not handle characters one by one. It handles group of repeated character. Okay. So let's saw let's saw raw data is. As our raw data is look like this, it is a list of tuple. Okay. So if 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 data, as an example we take data group equals to 3 and hash 4. So what is seems, this means hash appears 3 times. Okay. And the data group goes from each elements of inner list one by one, and the elements of list are tuples which having counts and symbol. So the tuple loop is saying इस रो के अंदर जितनी भी करेक्टर ग्रुप्स हैं उनको एक एक करके प्रोसेस करो. ओके. ओके. अंडरस्टैंड. नेक्स्ट. So inside the tuple loop we write count equals to data group 0 and symbol को क्या ले count equals to data group 0. Data group stores the value and data group stores the value of tuples. Okay. In a inner list. So count, you want to count equals to data group value of 0 index in the tuple. So 0. Next is the symbols symbol symbol equals to data group 1 which stores the value of second index in a tuple. Okay. This means count कितनी बार रिपीट होगा and symbol means कौन सा character repeat होगा. Okay. Now the program knows exactly what to print and how many times. So the tuple loop does not print characters directly, okay? It only prepares data for the inner loop. Understand? Loop 3, the core logic. This is the heart of the entire project. In this loop, the character is repeated count times and each time it is added to the string. Example, three hash occur 3 times. Here the compressed data is converted into visible ASCII art. Let's write the code for I in range count. COUNT count. Okay. Next one is the if count is greater than 0. Count is greater than 0. Line string equals to line string plus symbol. Okay. Okay. Now this is our final code. Now we have to print the ASCII line. For this we simply call print function print line string. Let's see. Let's run our code. Okay, it's showing one error where it is line string. Okay, it's in the loop. Let's call our function that is reconstruct ASCII art. Let's run our program. Okay, and this is our final ASCII art look like this. That's all for this video. See you in next video.